Topic 1 is an introduction to Arduino and its environment. Given the number and specific size of each box, I figured I'd take a photo of the layout for packing and repacking reference. Topic 1 simply requires basic familiarization with the components. The board acts primarily as a source of power, a basic circuit with a switch and an LED. It worked fine. I then played around a bit more and decided to add multiple LEDs in series and later in parallel. This got me thinking about a simple, quick-click game for 2 players to see who could light up their LED first. The result was 2 LEDs and 2 switches on either side of the breadboard in classic red versus blue. I then made an adaptation of the game with 2 switches but just 1 LED that allowed current to pass through it, through both switches, so that if both people pressed, the LED would intensify, thus showing who the second or slower player was. So finally, after some research, I found a cool tutorial on YouTube and decided to go beyond to play with my first sketch to see if I could make the native lights on the board itself blink and flash. This is the result of my first Arduino sketch. I made a light blink through just software and some programming, but it felt really great. In topic 2, we're building a spaceship effect, so the code and setup is as follows from the book. When you press the switch, the red LEDs do as expected. I also experimented with the look and feel when the delay is increased from 250 milliseconds to 1250. It looked a bit better. The end of chapter added challenge was to see if I could reverse the circuit so that the 2 red LEDs blinked by default, and when the switch was pressed, the green LED came on. That was a success. I simply switched the code blocks around. But then I got curious about pulse width modulation, and so I did a little research online to see if I could get the LED to fade in and out to create a cooler effect rather than the hard blinking that we'd seen so far. So with some digging and playing around, I managed to create this effect, which I think looks better than the book's initial activity. So that was topic 2, and I had some good fun with it. In topic 3, we're building a lavometer, which essentially is a temperature sensor that registers a change in temperature through voltage differences, which cause the LEDs to light up. We're then using the voltage differences to convert to degrees Celsius using the formula described in the book. The basic project worked great, and when I held on to the sensor, the heat caused additional LEDs to light up. Because my room is heated, the temperature registered at around 27 degrees Celsius. But then I got curious about how hot things could really get, so I rewired the circuit board. Building off projects 1 and 2, I created this custom danger flashing light system, and then I got started. The temperature hit 247 degrees Celsius, which actually shorted the last LED. Incredibly, the temperature sensor worked just fine afterwards, which shows the added applications of this setup to go beyond experiments at just room temperature. In topic 4, we're building a color mixing lamp that changes color when one or more of 3 colored photoresistors is affected. The wiring is becoming easier even though the project complexities are increasing. I set up everything as required and completed the sketch. The task worked great, and I began to understand more about analog to digital interfacing. So this got me thinking about a neat idea on how to combine topics 3 and 4, and so I decided to set up my own experiment. With some help from an online tutorial and the book Exploring Arduino by Jeremy Blum, both of which are in the bibliography, I used a temperature sensor from topic 3 to see if I could make changes in temperature affect the LED from topic 4. And basically have an order to it, so blue would be cool, red warm, and green would be perfect. The guidelines in the Exploring Arduino book only covered the basic circuitry, but I was able to extrapolate my own code from topic 3 to create and observe the serial monitor readouts and input my own values. This experiment worked amazingly well. I felt it was a bit overambitious at first, but now that it's worked, it feels really great, and it's a very nice way to end week 1.